right, we are continuing with lesson 8.1 and we're on task 3. Graph a piecewise defined function. A step function is a piecewise defined function that is constant over each interval of its domain. An example of a step function is the greatest integer function, denoted by f of x equals x, and you can see the x is in brackets. That represents the greatest integer function, which rounds the number x down to the greatest integer that is less than or equal to x. The greatest integer function is written here as a piecewise defined function, and the graph is shown. All right, so you can see that f of x equals -2 on the interval on the domain from -2 to -1. So from -2 to -1, you can see it's solid circle at -2, and it just represents that step there. This is not included, and you can see why that's a constant function there. And then the next one is -1. Again, it's solid at -1, so each one of those is represented by a constant function here. All right, which describes each interval, which describes each domain interval of the greatest integer function. All right, so the domain, all real numbers between two consecutive integers, including the left endpoint but not the right. All right, so it does include the left point because that's solid, and it does not include the right. All numbers between consecutive integers, including the right but not the left, that's not true. All real numbers between two consecutive integers, including both the left and the right. Well, it doesn't include both, it only includes the left. And all real numbers between consecutive integers, including neither the left or the right. So the first one is the correct answer. So all real numbers between two consecutive integers, including the left because it's solid circle, but not including the right because it's an open circle. All right, the domain intervals do not overlap. That's why one side is open. That way it's still a function. And for the domain, the interval is between, x is between a and b. Complete the function rule. All right, the point on the left was the solid circle, so that's the point it's going to be. So like this one's going to be -4, this one would be -3, etc. So it would have to be the point on the left, which is a. All right, what is the rule for g of x if f of x plus 3? All right, so remember this is a vertical translation, so this is going to move your function up 3. So if we move it up 3, that means the y values are going to move up 3. So if we look at f of x goes from -2 to 2. And we are going to move this one up 3. So if we move each one of those up 3, from -2 to -1 to 0 to 1, I think it should be that first one here. All right, so all it did, the domain pieces did not change. We just shifted the whole graph up 3 units. All right. To what point on the graph of G is the point 0, 0 on the graph of F mapped to? Select the correct answer from the graph. All right, so point 0, 0 on F is mapped. If we're going to move it up 3, it's still going to be at 0, it's still my X, but it's going to move up 3 on the Y. Your Y is your vertical movement. What is the rule for H of X if it's shifted to the left or right? All right, so x minus 2, remember this is x minus h, inside the parentheses moves it left or right. So this time we're shifting it on the domain part. Okay, we're shifting it left or right. So we're going to shift it from -2 to to -4, I believe. Let's see here. All right, so this time we just shifted horizontally. When we shift horizontally, left and right, that means our x, that's our domain, is moving. Okay, so that's why we went from up here, way up here. All right, so here we had -2, and it went from -2 to -1. Well, these numbers didn't switch, but the domain all shifted over 2 units. All right, and you can see that's how these shifted over 2 units. That's because this represents a horizontal movement. All right, to what point on the graph of H is the point 0, 0 on the graph of F? Show the correct answer from the drop-down menu. All right, so again, we're shifting it to the right 2 units. So X shifts, the Y does not shift. All right, what is the rule for J of X equals 3 times F of X? All right, so 3 times your Y value. So 3 times your Y value let's see. All right, so it changes these, but it does not change the part of the domain that we're looking at. So that one should be correct. All right, so this graph is a vertical stretch by a factor of 3. So that's why before, remember, it was -2, so on. So we just multiplied those by by 3. None of the domain part changed in that sense. All right, to what point on the graph of J, -2, -2 on the graph, select the correct answer from the drop-down menu. All right, so a vertical stretch of 3 means it multiplied the Y value by 3. So your Y value is the second number. So we're going to have -2, -6. All right, and what is the rule for K of X equals F times 1/2 of X? All right, so this is going to change the domain because you're dealing with the X's instead of the Y's. So the Y's, half of X. All right, so this one, these are the ones that I think are a little tricky. So this is a stretch on your X by 2 because it's 1 over B. And so this one would be, so the Y's will stay the same. The X's are going to change. All right, so let's see what it says. The graph of K is a horizontal stretch of the graph of F by a factor of 2. All right, so remember in the previous section where we graphed these, the B is inside the parentheses and it's 1 over B, and that makes it a stretch, which is why this gets multiplied by 2. So remember in the original one, it went from -2 to whatever, -2 to -1. And now it's just being stretched across this by a factor of 2. All right, to what point on the graph of K is the point -2, -2 on the graph of F mapped? Select the correct answer from the drop-down menu. All right, so your X was stretched by a factor of 2. So if my X is stretched it should change the X value and not the Y. All right, that's all for task 3. If you have any questions, please let me know. Lesson 8.1, task 4. Suppose you go to a used book sale where all the books are being sold for $3. A piecewise defined function can model the greatest number of books you could buy if you have a given dollar amount. Match the intervals of dollar amounts to the output number of books. All right, so if each book is $3 and I have between $0 and $3, 3 is not included, means I don't have enough to buy any books. All right, so if I have between $6 and $9, that means I should be able to buy 2 books. 2 books would cost $6, right? And that's included. And then 9 to 12, 3 books cost $9. 12's not included, so that goes there. And that means 5 books would be between 15 and 18. So 3 times 5 is $15. All right, explain why you answered part A represents Explain why your answer to part A represents a step function. All right, it represents a step function because the domain for each dollar amount is not included here. All right, which of the following shows the piecewise function intervals from part A using greatest integer function notation? All right, so we know that each book cost $3. So we're not multiplying by $3. We're actually dividing by $3. So if I have $18, I divide that by 3, I could get 6 books. If I have $21, I could divide that by 3 and purchase 7 books. So the piecewise function used would be the first one there. All right, compare the function in part A with part C. What is the advantage of each notation? All right, so the first part is a little bit easier to look at maybe and understand because we've done interval notation before. This one's just a little cleaner, shorter, and if you understand what the function's telling you to do, it's just kind of more precise. All right, apply your answer to part C with what is the greatest number of books you can buy with a $20 bill. All right, so if we look at the function, we have $20 divided by 3. Each book costs $3. 20 divided by 3 is 6 2/3. 3 times 6 is 18 and $2 left over. So the most number of books we could buy with a $20 bill would be 6 books. All right, that's all for task 4. If you have any questions, please let me know.